It turns out that there are some Boolean expressions that are quite complex, complicated, and quite tricky to deal with while using the Boolean simplification operations. Now, in a case like this, what should we do? Is there anything or any concept that can help us out? Yes, there is, and that concept is known as Karnaugh map. If you haven't watched my video about the introduction to Karnaugh map, check out the description of this video, or if you click on the link that just pop out at the top right hand corner of this video rather. I explain everything you need to know about the Karnaugh map. However, for this video, we are just going to be using the idea to deal with compound, complex Boolean expressions. Because using the Boolean expression simplification operations, it's not quite reliable. Yes, because it doesn't have a specific direction or specific process along which you need to deal with. Neither does it has a specific point that you need to end the solution. You just keeps on factorizing and keeps on simplifying. So I recommend you should always stick with this process and use it in all cases, as it can always work for any problems. The simplest one and the difficult one. So let's begin with an example for easy understanding. Assuming f is equals to a b prime c plus a b prime c prime. How can we simplify this using Karnaugh map? First, you need to observe the amount of input of variable that you are having within the function. Since we are having a, b, and c, then it means you are having three different variables as in the function. Now, what we are going to do is to raise to the power of the number of the variable, which is 3. Whatever value you have as a result will be the amount of squares you'll be having in the gamma. So in this case, for this problem, the result is 8. Therefore, I'm having 8 squares. It now depends on you how you want to arrange the squares. Is it in the vertical orientation or the horizontal orientation? I recommend you should only use the horizontal orientation, because for the vertical orientation, there are some things you need to work with again before you can have exact and appropriate results. So let's do that. So I'm using the horizontal orientation. For the horizontal orientation, for 8 squares, I'm going to be having 2 rows, 4 columns. At the upper part of the gamma, I'm having the first 2 inputs, AB, oh, bad. And at the lower part, I'm having the last input, which is C. For the lower part input, it can only insert 1 input at a time, which is no more than 0 and 1. And for the upper part inputs, they can insert up to 2 inputs all at a time. That's 0, 0, 0, 1, 1, 1, and 1, 0. So what we are going to do is to go back to the function. Whichever function that tends not to have bar or complement ahead it or over it, assume it is 1. Let me write it for easy identification. A, B prime C. Let me use bar, because some of you are wondering that what is complement, what is bar. They are the same actually. Plus A, B bar, C bar. So you know that for the bar, it's usually referred to 0. And for the single input, that's 1. This is 1. This is 0. This is 1. So now what you're going to do is to locate the box that correspond to this input. When A is 1, B is 0, and C is 1. Whichever box tends to satisfy this input, then you have to fill in that box with 1. So let's look at that. When A is 1, B is 0, and C is 1. So this is the box. So I'm going to fill in 1 to this box. Is there any other box that satisfies those inputs? When A is 1, B is 0, C is 1. Tell me that there's not. So next is to focus on the second pairs of inputs. When A is 1, B is 0, C is 0. which box tends to be the lucky box? This is when A is 1 and B is 0, and this is when BC is also 0. So therefore, that should be this box. I'm going to fill it with 1. Well, there's no another box that satisfies this condition. So, having done that, I will just fill other box with zeros. Now, if you could recall, in drawing out your final outcome using K-map, we don't need to focus on the boxes with zeros as they are irrelevant. We don't care about them. Our main goal is to focus on the boxes with ones. Now, let's group those ones in powers of 2. Well, it even turns out that we are only having two ones in this problem. So now, let's focus. How many rows and columns tends to be present in this pair or in this group? So we are having only one column and 2 rows. Okay, let me put that another way. So this is the 2 rows, first row and the second row. So let's check. In the first row and second row, which inputs tend to remain unchanged? It turns out that the only input is C, and it's actually changed in both cases. So therefore, we don't care about it. Well, now, what about the column? For the column, these are the inputs, and they remain unchanged. You can see they're just single. They are stationary. So therefore, that will be A, B. But since B is 0, it's going to be A, B complement or A, B bar, which will be our final answer. This is incredibly insane. You might be thinking this thing is quite bulky. It's something you can have your answer in just one click. Okay, it's also because I'm trying to explain and I want you to grab it once and for all. That's why I'm quite slow. You understand? But by the time you try to master this, you will eventually see the beauty behind it. Now let's consider more problems, and that's just it for this problem. By the way, if you haven't subscribed to my channel, please do well subscribe to my channel. Given that f is equals to a prime, b prime, c prime plus a prime, bc prime plus ab prime, c prime, then plus abc prime. Simplify this function using KARNAUGH map. So let's begin. First, we need to um, number each of these inputs as they occurred. The one with bar will be 0. The one with no bar will be 1. Okay, this will be 1, 0, 0. This will be 1, 1, 0. So right now I can draw my K-map. So I'm using the vertical part and the horizontal part. So I'm having 3 variables. So I'm having 8 boxes. So they are just 3. So at the upper part I have AB. Down part I have C. This can be up to 2, 0, 0, 0, 1, 1, 1, 1, 0. This can only be 1. So when all of them are zeros, I have an input to be 1. When A is 0, B is 1, C is 0. That is this part. That is this box. So that will be 1. When A is 1, others are 0. So that's this box. I'm going to feed that with 1. When A is 1, B is 1, and C is 0. That's this box. Right now, we can group the ones. Now we can see that all the ones are on a straight line. And also, they are in powers of 2 because that's 4. So therefore, we can just group them once and for all. Okay, it's allowed. You can group them once and for all since they are all side by side. So right now, let's focus on the amount of columns and the amount of rows. So this is the row and this is the column. So we are having 4 columns and just 1 row. So along the columns, is there any inputs that remain unchanged? A, B, it turns out that they all alternate. They all changes. Both A and B all changes. Okay, none of them will remain unchanged for the whole 4 columns. So what about along the row? Is there anyone that remain unchanged? That's C. So therefore, final answer for this, you can see how I got the answer without simplifying that much. If I should use the normal basic Boolean simplification operation. I knew the amount of time it will take me. You have to be thinking how to factor and so on. So the answer is just C prime because C is 0. And that's just it for this problem as well. Hopefully, you are getting the tactics. Let's consider one more for easy understanding. Number 3, if f is equals to a prime bc plus a prime bc prime plus abc prime plus abc plus ab prime c prime. Use schema to simplify this Boolean expression. I change my mind. I won't be solving it in this video. However, if you want me to solve it rather, you can comment in the comment section below. But first, try to solve it yourself and let me know your answer in the comment section. Thanks for watching. See you guys in the next video. Subscribe. Bye for now.